This idea comes from the perennial need to provide the user, in this case the user of your applications, of your forms, to provide the user with a tool which is at the same time both powerful and simple to query a database. This idea, in a sense, is the opposite of that forms which are crowded with combo boxes, select boxes, those forms which try to avoid the user to input any text. Because those forms, that way to query a database is too limited. But since there is no such thing as a free lunch, if the user wants more powerful, has to pay for something. In this case, the user is provided with a new language, which is basically a more forgiving and permissive and liberal way to write Boolean expressions. These Boolean expressions are then translated into full SQL queries by this model, which name is SQL QueryByForm. So the user can just concentrate on writing the Boolean expressions and don't have to think about the various SQL clauses such as where or from. The select is automatic because the form is bound to a DB table, a single DB table, or anyway a DB object which can be seen as a table, such as a view, for example, a database view. Okay, I was preparing, I've been preparing in these last days some slides, but then I thought, why present you something, a formal specification of the language which could have been boring, or just some examples on the paper, when we can actually run these examples. So, no fiction here, there is a real application, a real working application, hopefully working application. A Catalyst-based application, a web-based application, which connects to a PostgreSQL backend, and the query are really executed against Postgres. So we can see how this language works through a series of examples. And okay, this is the application, a fictional YAPS 2010 dating service. And now we'll try to impress you. Okay, here is how the language works. Let's suppose that we are looking for some friends. For example, we're looking for a person whose name is Mary. So I write down Mary. I click on Find People. And I found a person called Mary. Anyone impressed?
Not yet.
You should really, since there is a trick, there's already a trick here.
Interesting tree is interesting for the animation.
Where's the address?
Okay, here is the first trick. When you input some literal value, you don't have to quote it. This model tries extremely hard, very hard, to avoid the user to type the quotes, unless there is some unavoidable ambiguity. In this case, the quotes are necessary, of course. So we can use the quotes if we want, here is the generated code. You can see right from here that the query, the values, the literal values are extracted from the query and passed back to the D as int values for security reasons, of course. Okay, so we can use for literal values double quotes or single quotes or even mixed quotes. This is a typical mistake. So we forgive this mistake. We permit the user even to use the wrong quotes, an opening quote and a different quote for closing, or a single quote. It works. The same. Here is the generated code. The model automatically understands that this is a literal value, even if it has a single quote, and correctly finds it. Okay, let's see something more difficult. The name is Mary or Marianne or Mary Jo. Note that we don't need to quote anything even when the literal values contains some spaces inside. And we find all the person who have these names. Here is the generated code. Okay, let's see something more difficult.
Very Joe is short. Very Joe is short.
So it's short, but it's rich. Okay. We can use, if we use inside the literal value, even without quotes, an SQL wildcard, it is automatically recognized, and alike is I like in this case, but in this model, pretty much everything is customizable. The user can decide to translate this automatically with an I like or alike. This is translated into alike automatically. Of course, the user can use alike if he wants. It's exactly the same. And if we want to avoid this automatic interpolation, we have to quote the value. And in this case, we would look for Mary with a wildcard which does not exist. Here is the generator.
Quindi la stessa cosa se il cognome fosse oro.
Sì, yes. Allora, let's see something even more difficult. Okay, we are looking for all the girls whose name begins with Mary, but we don't want Marianne, but Marianne. So if I Mary Jo, but is translated into and not. Also, this is customizable. The user can add all the Boolean operator he wants. But it's just an example. Can add, for example, but not or except, and so on. Here is the generated code. Okay, something more difficult. Now, okay, let's suppose that we are looking for someone young. We can use a relational operator without specifying anything else, and the literal value. These are all the people whose age is under 30, but young, but not that young, so you can write something like this. Or, in an equivalent manner, between 20 and 30. Okay. The result is the same. something more difficult. This is a very interesting feature of this module. Inside an input box, which is bound to a certain DB field, we can reference also another field of the table. For example, we're looking for a young person, but we are willing to have an older person if she is rich enough, just because we're not big enough. And we can write this condition, or less than 60, provided that income is greater than 1 million. Okay, as you have seen here, this is very interesting, even the field names don't have to be quoted. The model automatically recognizes the field names through their aliases. For example, the user don't know if the field name is income or annual income, and it works the same. If the user types annual income, it works exactly the same. The full rule is to quote, to avoid any ambiguity, the field names with square brackets. But this model permits you to avoid the square brackets and any other quotas whenever possible. So it's really very hard to avoid that. Okay, here, as you can see, it's not necessary to use parentheses, brackets, since the AND operator has an higher priority than the OR Boolean operator. So this is evaluated in the corrected order. But if you want to add something else, such as, okay, we are willing to accept someone which is not so young and not so rich if he or she is very tall or her name is Marco, because we like him. In this case, the brackets are necessary because we have an OR inside the brackets. And you can build this way basically any Boolean expression with nearly no limitations. And this is very similar to the form-based filter provided by Microsoft Access. I don't know which is the correct name in English. In Italian is something like form-based filter. It's inspired by the functionality of Microsoft Access. It's probably better because Microsoft Access is not so smart, for example, in understanding